All right. 203 midterm problem 8b. The Fourier series coefficients of a periodic signal y of n with period n equals 6 is a sub 0 is equal to 1, a sub 1 is equal to a sub negative 1, which is equal to 2, and we want to know what is y. So we have y of n, and we can use the top formula over here. So that's going to be equal to the sum over capital N of a k e to the j k omega naught. Now, n is equal to 6. That's our fundamental period. And that's equal to 2 pi over omega naught. So omega naught is equal to pi over 3. And we have a negative 1 is equal to a of 1, and that's equal to 2, and a of 0 is equal to 1. So this is our k, this is a k, this is a k, and this is a k. So y of n is going to be equal to, we'll do the term with a k equals negative 1, and that's going to be added to the term with a k equals negative, or excuse me, equals 1 plus the term with a k equals 0. So we do that and we get well, a, so this when k is equal to negative 1, then a of k is equal to 2, and it's e to the j negative 1 times omega naught, which is pi over 3, times n. And that's going to be added to 2 e to the j 1 pi over 3 times n, and then plus 1 e to the j 0 pi over 3 times n. And we write this out, we get, let's factor out this 2, so we get 2 e to the negative j pi over 3n plus e to the j pi over 3n plus 1 to the e j 0. And we can write this out a little bit more. We get 2 e to the j pi over 2 times n plus e to the negative j, oh, excuse me, this is a 3 right there. But, so then 2 times the quantity e to the j pi over 3 times n plus e to the negative j pi over 3 times n. And then this term, e to the j 0 is equal to 1, so we have 1 times 1, that's 1. And if we multiply the outside by 2, so we have 2 times 2, and then we multiply the inside by 1/2, we'll have e to the j pi over 3 times n plus e to the negative j pi over 3 times n plus 1. And here's our cosine term. And what we end up with is 4 times cosine pi over 3 times n plus 1, and that's equal to y of n. And I will be back with part C.